Hello, students. Welcome to Inside Physics. Today, we are going to discuss the refraction of light through a prism. See, we already studied what is refraction in previous classes, the bending of light at the interface of two mediums. If it is passing through one medium to another medium, at the interface or border of the two mediums, it will bend because the change in density of the two mediums makes the change of speed or velocity of light in the two mediums. So here the a prism is made of a thick lens material, thick glass or any material which is made of some thick material, and the sides of the material, the prism are thick. These prism will make the incident ray refract through the prism, and the emergent ray will be coming out of the second face of the prism. So in between, the prism is also has a property of making the white light ray is dispersed. So the dispersion of light ray, that means the dispersion is splitting of white light into constituent colors. So here we see the refraction, and thereby we will calculate the refractive index of the prism. See, what is refractive index? In previous class we have discussed the refractive index mu, or it can be denoted by n21, that is equal to n2 by n1. So refractive index is, see, the relative bending of light when it is passing through one medium to other medium. See, n to 1 means it is passing through medium 1 to medium 2. So at the interface of the two mediums, the light ray will bend while entering into the second medium, because the densities of two mediums will be changing, and thereby the speed of light is also changes in the medium. Refractive index is, we know that c naught by cm, where c naught is the velocity of light, speed of light in vacuum or air, and this is speed of light in a medium. So the ratio of the speed of light gives the refractive index. Refractive index doesn't have any units because it is a ratio. It tells something about the amount of bending of light ray at the interface of a two mediums. So something, if you say that the refractive index of a medium is 1.5, so it means to say that it bends this much times when it is entering from one medium to other medium. Suppose medium 1 to medium 2, the bending, see, the amount of bending will be the multiple of this one, 1.5. So that is the meaning of refractive index. So here we see, by calculating refractive index of the prism, we can understand and study what type of material it is, so, and what type of material it is made of. So here, with the help of principles of refraction through a prism, we will calculate the refractive index of prism and angle of deviation. See, what is angle of deviation here? This delta is represented as a angle between incident ray and emergent ray. So if you observe, this incident ray is extended and this emergent ray is extended backwards into the prism. Okay, even though it is not a real line, we can extend, and this angle between the incident ray and emergent ray is called angle of deviation. See, deviation, the original ray is like this and the final ray is like this. That means the original ray and the emergent ray, incident ray and emergent ray, the angle between these two, that means the how much the ray is bending while entering into the prism and while leaving the prism. So in this way, the angle through which it is deviated while passing through the prism is called angle of deviation. So if here in this diagram, if you observe closely, we have some symmetries of angles, and thereby we will have some equations of symmetry. See, AQNR is a quadrilateral. If you observe this one, AQNR is a quadrilateral. Here, this is the perpendicular to this face of the prism, this one, and this is the perpendicular drawn to this face of the prism. See, this is a perpendicular, this is a perpendicular. So if you observe the quadrilateral AQNR, these two triangles, see these AQN and ARN triangle, these angles are perpendicular angles. Okay. See, AQN and ARN are perpendicular angles. That means 90 degrees. So both of these two add together is 180 degrees, right? See, angle AQN plus angle ARN is equal to 180 degrees. This one and this one. So here, by the angle principle of the quadrilateral, see, angle A and angle N, angle A, QAR and QNR, we can write angle QAR plus angle QNR is equal to 180 degrees. So this is a quadrilateral and sum of all the angles is 360 degrees, right? Here, see, this angle QNR is this is angle A, right? A plus angle QNR is equal to 180. This angle is angle of prism. This is called angle of prism. Okay. So here, see, if you observe, this is a triangle. See, IQNR is a triangle. So sum of the all angles in a triangle is called, sum of the angles is 180 degrees, right? If you can write this one, angle QNR plus R1 plus R2 is equal to 180 degrees, right? This is a QNR is a triangle. The sum of all the angles in a triangle is 180 degrees. So that we can take R1 plus R2 plus angle QNR is equal to 180 degrees. If you observe these two equations, we can write by these two, R1 plus R2 is equal to A, right? R1 plus R2 is equal to A. We can write this equation. Okay. So here, if you observe again, see, this is I, this is R1. So this is E, angle of emergence. This is the refracted angle for the second phase. Okay. If you observe this one, this angle is I, this is R1, this is a perpendicular to the face, and so by symmetry we can write this angle as I minus R1, right? Again, if you observe, this is emergence angle, this is the angle of refraction for this face, and this is the perpendicular drawn to this face. If you want this angle, we can write thus, this is subtracted, E minus R2 gives this angle, E minus R2. See, E minus R2, because this is a perpendicular, this is the angle of emergence, this minus this gives value of this one, right? So in this way we can write, see, I minus R1, E minus R2, and here if you observe this triangle Q, if you suppose you take this as point D, suppose this contact point. QDR, in this QDR triangle, if you observe, E minus R1, E minus R2 is interior angles, and for this triangle delta is the exterior angle, right? These two angles are interior angles for this triangle QDR. These two are interior angles. This is the exterior angle. So we can write, by the properties of triangles, we can write this as EI minus R1 plus E minus R2. Delta is equal to angle of deviation is equal to E minus R1 plus E minus R2. That is equal to, this is okay. So I plus E minus of R1 plus R2, that is equal to I plus E minus A. What is A? R1 plus R2, sum of two refracting angles I plus A. So delta is equal to I plus E minus A. We can write in this way. Okay. See here, this is the equation we got for delta, angle of deviation. See, if angle of incidence is equal to angle of emergence, suppose angle of incidence is equal to angle of emergence, that means I is equal to A, I is equal to E. Okay, then the angle of deviation will be the minimum at its minimum when I is equal to E. So that is called angle of minimum deviation. That is called angle of minimum deviation. So when I is equal to E, we can write R1 is equal to R2, right? When I is equal to E, we can write R1 is equal to R2. And at I is equal to E, we can write delta is equal to dm, that is angle of minimum deviation. Delta is equal to dm, angle of minimum deviation. So by this, what we can write the equations is, see, this is angle of deviation and delta m, angle of deviation. So when I is equal to E and R1 is equal to R2, see this equation, we know that R1 plus R2 is equal to A, right? So this becomes R1 plus R2. When you write R1 is equal to R2, so here it becomes 2R is equal to A. So R is equal to A by 2. Okay. You can take both are equal. You can take this value as small r. So R is equal to A by 2. R, angle of refraction, is, see, angle of prism, half of the angle of prism. Okay. So here, see, if delta is written as angle of minimum deviation at I is equal to E, what it becomes, this equation. So I plus I minus A. Okay. Okay, I plus A, I plus I minus A. By this we can write I is equal to E. If I is equal to E, angle of deviation becomes angle of minimum deviation. So by this we can write 2I minus A is equal to dm, right? So here, see, if you observe, 2I is equal to A plus dm, and see, I is equal to A plus dm by 2. Okay, if you observe this one, angle of incidence, angle of refraction, see, angle of incidence is A plus dm by 2, angle of refraction is A by 2. See, we know that the refractive index of a material, or in this case a prism is can be written as n21 is equal to sin I by sin r, right? Sin I by sin r. So here refractive index n21 is equal to sin of a plus dm by 2 by sin a by 2. Okay, see sin I, in place of I have put this value sin I, this value. In place of r I have put r is equal to a by 2. So refractive index of the prism can be written in this form, and in this formula angle of prism and minimum deviation angle we can find out experimentally what is a, what is dm. Okay, see here if you observe with graph, we will have one graph to observe the angle of deviation and the angle of incidence, the relation between angle of incidence and angle of deviation. See if you draw a graph between angle of deviation and angle of incidence, suppose we take 20 degrees, 40 degrees, 60 degrees, 80 degrees, this is 0, this is like something, see 20, 40, 60, 80 angle of deviation. See at a point of time the deviation will be minimum and it will again deviation will become maximum. So at a particular point, so the deviation is minimum where this condition occurs at I is equal to E, angle of incidence is equal to angle of emergence. At angle of incidence is equal to E, that means we can reverse the emergent ray and incident ray, then also the angle of deviation will not change. At this condition, if you reverse angle of emergent ray and incident ray, if you reverse these two rays, then also the angle of deviation will not change at this point I is equal to E. Okay, so angle of minimum deviation at I is equal to E condition is minimum, and again it will be moving up. So this is angle of deviation on y-axis and this is angle of incidence on x-axis. Okay, so here see with this formula, if we take some a thin prism, for a thin prism which for which the angles are very small, if it is a thin prism, we can write this same formula as, see if we exclude sine because the angles are very small, we can write a plus dm by 2 by a by 2. Okay, so we can write for small angles of prism, if you take a thin prism you can write like this. Okay, see with this we can write sine refractive index n21 is equal to a plus dm by 2 by a by 2. So this 2 gets cancelled, that is equal to n21 is equal to a plus dm by a. 2 gets cancelled, so that is equal to 1 plus, if you take these values 1 plus dm by a. Okay, so here if you want to take the value of dm, angle of minimum deviation, okay, from this we can, you can write dm is equal to n21 into a minus a, right? That means dm is equal to n21 minus 1 into a. Okay, see, with this equation we can say that angle of minimum deviation is very small and the prism will not deviate that much. That means the deviation of the light ray is not so big, it is a very small angles. So in this way we can calculate the refractive index and angle of minimum deviation. These two properties are the important properties of a prism: angle of deviation, angle of minimum deviation when I is equal to E, and the refractive index. What we have got, refractive index is sine of a plus dm by 2 by sine of a by 2. So these two formulas can be derived in case of refraction through a prism. Okay, see, in the next class we will move some optical instruments and we will see how they work in with the principles of reflection and refraction. Okay.